All right, let's dissect this paper on Rationalist. It tackles the issue of incomplete reasoning steps in LLMs, a common problem stemming from their pre-training data. The core idea is process supervision during reasoning. What's the novel approach Rationalist takes to address this?
The novelty lies in its pre-training on a massive collection of implicit rationales extracted from unlabeled data. Existing methods often rely on explicit, human, annotated rationales, which are expensive and time-consuming to obtain. Rationalist sidesteps this by using LLMs to automatically extract these hidden logical connections from both web-scale datasets, like the pile, and smaller, curated reasoning datasets.
So you're essentially teaching the LLM to identify and utilize the unspoken why behind reasoning steps found in natural language. How does the extraction process work in detail?
It's a multi-stage process. First, they pre-filter the unlabeled data to select reasoning-rich documents. Then, an LLM generates potential rationales, which are then filtered based on how well they predict subsequent text. This ensures that only helpful rationales are retained for training. They also extract rationales from existing reasoning datasets to improve the model's performance on specific reasoning tasks.
Interesting. The filtering step is key to avoid noise. What's the metric used to determine if a rationale is helpful?
They use a weighted cross-entropy loss for future token prediction. Essentially, a rationale is considered helpful if adding it significantly reduces the model's perplexity when predicting the following text. This is a clever way to objectively assess the usefulness of the extracted rationales without relying on human judgment.
And how are these extracted rationales then used to improve the LLM's reasoning abilities?
Rationalist is trained to predict these implicit rationales given the preceding context. During inference, another LLM, the agent, generates reasoning steps. Rationalist then provides supervision, either implicitly, by scoring the likelihood of the next step given the rationale, or explicitly, by incorporating the rationale directly into the agent's input.
So it's a two-model system, one generating reasoning steps and the other providing guidance. What are the comparative advantages of implicit versus explicit supervision?
Implicit supervision, using probability-based heuristics, proves more robust to errors in the generated rationales. Explicitly incorporating potentially flawed rationales can lead to cascading errors in the reasoning process. Implicit supervision acts as a softer guide.
The paper mentions several benchmarks. How does Rationalist perform compared to other methods, including larger models like GPT-4?
Rationalist consistently outperforms both a vanilla Llama 3.8b instruct model and even GPT-4 when used for process supervision. It also surpasses outcome-based verifiers fine-tuned on the same datasets, highlighting the benefits of process-level supervision. This is remarkable considering Rationalist's smaller size.
That's a strong result. What are some of the limitations and future directions mentioned in the paper?
Scaling up Rationalist with larger models and datasets is a key area for future work. The current experiments are limited by computational resources. They also plan to explore different combinations of rationales from various datasets and investigate the integration of Rationalist with more advanced test-time computation techniques.
The paper also touches upon the necessity of training on extracted rationales. Why is this step crucial in their view?
They argue that while pre-training on large datasets like the pile is beneficial, fine-tuning on extracted rationales provides additional value. Rationales encapsulate the reasoning process more directly than the full text, leading to more effective improvements in reasoning capabilities. Also, many LLMs are already trained on datasets like the pile, so the marginal benefit of further training on the same data is likely lower.
So it's not just about the quantity of data, but the quality and focus of the information used for fine-tuning. What about the interpretability aspect? Does Rationalist offer any advantages there?
Yes, the generated rationales are designed to be human-readable, improving the interpretability of the LLM's reasoning process, especially for complex tasks like mathematical reasoning. This is a significant advantage over methods that solely focus on optimizing for accuracy without considering interpretability.
This is a compelling argument for a data-centric approach to improving LLM reasoning. The ability to leverage unlabeled data to extract implicit rationales is a significant step forward. What are the key takeaways from this research for practitioners?
The key takeaway is that focusing on the process of reasoning rather than just the final outcome can lead to significant improvements in LLM performance. Rationalist demonstrates the effectiveness of a data-centric approach, leveraging readily available unlabeled data to improve reasoning across diverse tasks. The method's relative simplicity and robustness to noise are also attractive features.
The use of implicit supervision as a more robust approach is also noteworthy. It's a clever way to handle the inherent uncertainty in automatically extracted rationales. Are there any specific applications where this approach could be particularly impactful?
Any application requiring robust and explainable reasoning would benefit. This includes areas like scientific discovery, medical diagnosis, legal reasoning, and complex problem solving in general. The ability to generate human understandable rationales is particularly valuable in these high-stakes domains.
The fact that it outperforms larger models in process supervision is quite intriguing. What might account for this unexpected result?
It's likely due to rationalists' specialized training on implicit rationales. GPT-4, while a powerful general-purpose model, may not be as finely tuned for the specific task of providing process-level supervision during reasoning. Rationalists' architecture and training objective are specifically designed for this purpose.
So it's a case of specialization versus generalization. A smaller, specialized model outperforming a larger, more general-purpose model on a specific task. That's a valuable lesson in model design. Thanks for this insightful discussion.